Okay, today at 9.1b, we are continuing with our sequencing, but today we are going to cover more factorials and summations. So we did cover a little bit about factorials, but today we're going to reduce factorials. So if I had something, let's say 4 exclamation mark over 5 exclamation mark, we know that this is the same thing as 4 times 3 times 2 times 1, and the denominator is 5 times 4 times 3 times 2 times 1. Well, these can be reduced accordingly, right? Simplified to 1. So this simply just gives me 1/5. What if I had a little bit more of a complex one? What if I had multiple factorials? So let's say I had 9 factorial over 3 factorial, 6 factorial. Well, you have to keep in mind that this is 9 times 3 times 2 all the way to 1, and 3 all the way to 1, and 6 all the way to 1. So if I reduce this 6, right, because that's the biggest one in the denominator, and I reduce that from my 9, this gives me, if I get rid of the 6 and reduce it all the way down to 1, then there's a 3 factorial, and then from 6 all the way to 1 is gone. So I'm left with 7 times 8 times 9. So this is 7 times 8 times 9 divided by 3 times 2. This can be, you want to simplify it a bit more, right? Now we can, there's a 2. Well, this is 4, 3. This is a 3. So 7 times 3 times 4. So that equals 84. If you punch it in, or 7 times 3 is 21. Yep, 84. 21 times 4 is 84. Moving on, some other. What if we had factoring expressions with variables? Well, we can always reduce our factorials if we head it towards going backwards, right? If we had, everything can be worked backwards to meet the factorials. So we had a variable factorials of, let's say, n plus 3 factorial divided by n minus 1 factorial. Well, the plus 3 is larger, so we can always work our way backwards to meet that n minus 1. So I can expand this to say n plus 3, n plus 2. It's like you're counting backwards, right? Like 9, 8, 7, 6. Well, this is 3, 2, 1. And then here with a simple n, right? 0, so with an n. And then n minus 1 factorial. And then there we meet our n minus 1 factorial. So then we can simplify this by reducing these two parts. So n plus 3 factorial divided by n minus 1 factorial is actually n plus 3, n plus 2, n plus 1 times n, all the way across like so. We can do another example that here, let me show you. Let's say we have n factorial over n minus 2 factorial. Well, the minus 2 is the, well, let's say plus 2. Let's say plus 2. The plus 2 is the larger one in this case. Then we need to go backwards to meet the n factorial. So this becomes n factorial over n plus 2, n plus 1, and then n factorial. So there we can reduce this. this becomes 1 over n plus 2 times n plus 1. And you could FOIL that out, but not necessary. Next, let's talk about summations. A summation, just a quick reminder, is a sum, and it comes with an epsilon side. So we'll start out with an I, and it usually starts at a point, right? Any point. So let's say I equals 2. And this is where you want to start out with. And then at the top is going to be where they end up finishing. So let's say this is 4. And our summation point is, let's say, 1 over I squared. Well, you start with 2. So this is the same thing as saying 1 over 2 squared. So that's 2 squared plus, because summation is you're adding them all together, 1 plus 2 squared plus 1 over 3 squared plus, and you stop at 4, so 1 over 4 squared, which gives us 1/4 plus 1/9 plus 1/16. Plug that in to our calculators. And I got 61 over 144. Let's do another example of a summation. One last example here. Let's try one that's a little bit more difficult, I guess. We'll say it a little bit more difficult. Not difficult, just more. So let's say we have a summation of k equals 1. So we'll start at 1, ends at 6, and it's 7k plus 2 squared k minus 3. So now we just gotta plug it in and add them up. So the first one is 1, right? So 1 plus 2 is 3 squared. So this is 7 times 3 squared plus negative 2 times negative 2 plus, so now we do 2. We did 1, so 7 times 2 plus 2 is 4 squared. 2, that's negative 1. Now we do 3, so 7 times 5 squared plus 0. Oh, that's easy. Plus 7, so now we do, so let's see, 1, 2, 3, so now we're on 4. So this is 6 squared times 1. Now we're on 5. 7 times 7 squared plus 5 minus, that's 2. And then finally the last one, plus 7 times 6, that's 8 squared, and times 3. So now we just gotta combine it all and see what we get here. We have, for the first one, let's see here, 9 times 7 times negative 2. That gives me negative 126. 4 squared times 7 minus 112, plus 0. 36 times 7, that gives me 252. 49 times 7 times 2 plus 686, and then the last one, 64 times 3 times 7 gives me 1344. Add all that together. 126 minus 112 plus 252 plus 686 plus 1344, and we get 2044 for that summation from starting at 1 ending at 6.